In this video, we're going to talk about the production process. In particular, we're going to talk about the resources that firms use, the concepts of the short run and the long run, and the relationship that occurs between the total product and the marginal product functions. As we discussed earlier in the course, the basic resources that are used to produce output are also known as inputs or factors of production. We define them as land, which we now normally call natural resources, labor, the productive power of human beings, capital, which represents the plant and equipment that's produced in order to produce output. Remember, it's not financial assets, it's the actual physical goods that are used to produce other goods. And entrepreneurial ability or entrepreneurship. This is the ability to organize production and to choose the mix of inputs that will be used to produce output. Another concept that's important is that of technology. And technically, technology isn't an input, but it's the knowledge or the know-how of how we can convert inputs into output. So when we say there's technological improvements, what that means is that we're able to combine inputs in a way that gives us more output from our existing inputs. In microeconomics, when we talk about the time horizon, there's two definitions that we use. The short run is defined to be the period of time in which capital is fixed. The long run is the period of time in which all inputs are variable, including capital. Notice this isn't a fixed number of days or weeks or months. It's going to vary depending on the type of production process. If you have a lawn mowing business, it might only take you an hour or two to get additional lawnmowers. If you're building cars, it may take you 3 to 5 years to design and create an assembly line to produce a new model of cars. So the length of the short run is going to be defined by how quickly new capital can be created and introduced into your production process. In some industries, that'll be very short. In other periods, that could be a very, very long period of time. One term we use in discussing production is a production function. And in its simplest form, we can write this as the quantity of output is a function of the amount of labor and capital, where in this function, L stands for the amount of labor, and K stands for the amount of capital. We'd use C, but we're using that for costs and other things in this course. So we adopt K to stand for capital, and it's a pretty standard usage in economics. You may wonder what happened to the other inputs. We're just going to simplify this to make the analysis easier, and you can think of labor as representing all those inputs that are variable in the short run, while capital represents those inputs that are only variable in the long run. So in the short run, capital is fixed, so this production function simplifies to what we call a total product function, which is now just a function of the amount of labor. The image now on your screen contains a graph of a total product function, which is, again, the relationship between the amount of output produced and the amount of labor used. Initially, when you start using additional units of labor, output is increasing at an increasing rate, but eventually you get to some point where output starts to increase at a slower rate, and the curve changes from being convex to being concave. At some point, the curve may reach a maximum, as illustrated here, and at that point, adding additional units of labor is not going to result in any further increases in output, and beyond some point, output will actually begin to fall. The reason for this is these workers are working with a fixed amount of capital. At low levels of output, you have a small amount of labor trying to do many different tasks, and they're spending a lot of time shifting from task to task, and they're going to be losing some time in that process, and they're not going to be quite as proficient at any one task when they're constantly changing tasks. As we add more workers, we're able to assign workers more efficiently, and that will result in larger increases in output. That's the convex portion of this total product function. But eventually, with a fixed amount of capital, the additional output you can produce starts to fall. And this is a concept you've seen before, and we'll come back to it in just a couple minutes. We can also use a table to represent this. When you have no labor, you have no output. When you add the first 5 workers, output goes up by 50. When you add the next 5 workers, it rises, in this case, by 70. That's the portion of the curve where it's rising at an increasing rate. When you add the next 5 workers, output goes up by 60, which is a little bit less than before. So we've already moved into the concave portion of this curve. When we add 20 workers, we have 220. 25 workers, we have 250. When we get, in this case, to 35 workers, though, if we add 5 more workers, output stays at 275, and that would correspond to that range at the top of the total product curve. And when we move to 45 units of labor, we're now in the downward sloping portion of the total product curve. So this is a type of relationship we'd expect to see between labor use and output when there are fixed inputs such as capital. The marginal product is defined to be the change in total product divided by the change in labor. We can also think about this as being the additional output resulting from the use of one additional unit of labor, or from the last worker. We can use data in this table to compute this marginal product. For example, suppose we look at the interval where labor use rises from 10 to 15 workers. What we observe is that output increases in that interval from 120 to 180. So to compute marginal product, we take the change in total product and we divide that by the change in labor. When we do that, we get the change in total product is 180 minus 20, which is 60, divided by 15 minus 10, which is the change in labor, which is 5. And that gives us a ratio of 60 over 5, or 12. So in the interval between 10 and 15 units of labor, the marginal product is approximately 12. Now, I filled in the rest of this table. When you go from 0 to 5 units of labor, output rises by 50. So we get a change in output of 50 divided by 5, which is just 10. When we go from 5 to 10 units of labor, output rises from 50 to 120, which is 70. 70 over 5 is 14. When we go from 10 to 15 units of labor, output rises, as we have already determined, by 60. So 60 over 5 is 12, and so forth. When we look at the interval between 35 and 40 workers, output doesn't change, so marginal product is 0 for that interval. And beyond that, output falls by 5 units when you use 5 more units of labor. So marginal product would just be a negative 5 over 5 or a negative 1. What this relationship is illustrating is the law of diminishing returns. We can state that more formally now by saying that the law of diminishing returns states that the marginal product eventually declines as additional units of a variable input are used when other inputs are fixed. We can also represent these relationships using a graph. The diagram in the top right of this screen shows that total product curve, and there's 2 points that are illustrated there. The first is a point where the production function changes from being convex, which means it's increasing at an increasing rate, to where it becomes concave, where it's increasing at a decreasing rate. Some of you may recognize this as what's called an inflection point. And the other point which is highlighted there is a point where total product reaches a maximum. The inflection point for the total product curve is the point where marginal product stops increasing, because if output is increasing at an increasing rate, the marginal product of each additional worker must be rising. But once we get past that inflection point, the output of an additional worker is falling, and we observe that in that range, total product is rising, but it's rising at a decreasing rate. Once marginal product equals 0, the total product curve reaches a maximum, and beyond that point, total product is declining. These relationships are going to be important in explaining how costs change, and we'll turn to those topics in subsequent videos.